Hello, mathematicians. Okay, we are moving on to the next step of exponential functions. We are actually going to use them out in the real world, apply them to actually things that you will do in life, like money and interest and that sort of thing. Now remember, a growth function is actually when our amount is growing over time. So remember, it is rising. So I am going to talk about growth functions and how to work them. Then we're going to talk about decay functions. If you find that the video gets a little long, go ahead and pause for a little bit, come back and finish the video. Okay, growth functions. We always use this exact same equation. So once you get to know this equation, you're good for everything that's growing. Now, let's go ahead and look at what all of those terms mean. Now, first of all, we are going to start with A. A is the initial amount. That means how much are you starting with? So whether I'm talking about mushrooms or people or zombies or money, what is our start value? How much money are we starting with? Then what we're going to do is we are going to find our growth factor, our rate. Notice that there is an R here, 1 plus R. We are going to look for how fast is it growing, by what number is it growing, and then we always add it to 1 because you have your original population plus the new group. So R plus 1 will help us with growth. And then finally we need R to the T power. T is time. So how long are we watching this growth occur? So as we go through the word problems, we're going to be looking for what is the starting amount, what is the rate at which it's growing, and how long is it growing? So I'm going to go ahead and start with example 1. I'm just going to read it and try to understand what's going on in the problem. The population of a town is currently 8,250. It has been increasing 3% each year. What will be the population in 10 years? Okay, so let's go ahead and take a look. This problem is talking about people that live inside a town. I do notice that our initial amount, our starting, is 8,250 people. That's how many people are in town. Now that town is growing. Notice it says increasing 3% each year. And then they ask me, what will be the population in 10 years? So there is my time. Oops, I just highlighted it wrong. That should have been green. I'm trying to pay attention here. Okay, green. So notice I have my initial amount, my rate of growth, and the time at which I'm studying this. So let's go ahead and start with our equation. Y equals A times the quantity of 1 plus R to the T. So let's go ahead and start plugging in our information. RA is 8,250 times the quantity of 1 plus our rate. Our rate is 3%. We can't do percents in equations. They have to be turned back to decimals. 3%, if I want to turn that into a decimal, I take my decimal and I move it twice. I can explain why that happens, but know that you move it 2 times. So now I have 0.03. And my T, my time, is 10 years. So I'm going to simplify it a little bit before I put it into my calculator. I have 8,250 people times the rate of 1.03 to the 10th power. Let me show you how to type this in on your calculator. I believe yours are the same as mine. So 8,250 times 1.03. Then I'm going to use this caret. This is telling me that there is an exponent, and I'm going to put 10 is my exponent. And then I'm going to press equal. Wow, that's a lot of people. In 10 years, there will be 11,087 people. I'm not going to use the 0.3 because you can't have a third of a person. So it is equal to 11,087. So that is how many people will be in this town in 10 years. Okay, let's try the second one. The starting salary at a job is $24,000. The job offers an increase of 1.5% each year. How much will an employee make after 6 years? Okay, let's go ahead and see. We're talking about money, how much money we're making. And notice that our starting value is $24,000. The job offers an increase of 1.5%. Increase means it's going up. And then finally, we want to know how much the employee will make after 6 years. So now that we have our three values, we can go ahead and use our equation. Y equals A times 1 plus R to the T. Our starting value is 24,000 times 1 plus, notice my percent cannot be used in an equation, so I have to move my decimal twice. So it's 0.015 to the 6th power. So let's go ahead and put that into our calculator. Okay, I've got 24,000 times 1.015 to the 6th power. Okay, I've got 2, 6, 2, 4, 2 point, and we're talking money, so I need 2 decimal spots. Okay, so after 6 years, this person will be earning $26,242.64 per year. That, oh, I'm going to put my money sign back there. There we go. And we are done with growth. Now, let's go ahead and take a look at decay functions. Now remember, decay functions, if I draw my coordinate plane, my decay functions are going to start high, but then they're going to drop. So notice it is falling over time. So let's go ahead and take a look at our equation here. Very, very similar. Notice, very similar. I've got y equals A times the quantity of 1 minus R. This time I'm going to subtract the rate, and I still raise it to the power of time. Okay, so notice that A is still our initial amount. Our rate, this time we're going to subtract it. It is how far is it falling each time. And time is going to be T. So let's go ahead and read our problem and start looking for our values. Yasser bought a car in 2012 for $16,000. The car's value has been decreasing at a rate of 7% each year. How much was the car worth in 2018? Okay, so we're talking about a car and its value, because cars lose value over time. So I need to know the initial amount of the car. It was $16,000. Now I need to know the rate. We know that it is decreasing at a rate of 7%. And then I need to know the time. How much time has there been? Oh, it didn't give me the year. But I do know that from 2012 to 2018 is 6 years. So that means this person has had it for 6 years. So if I need to, I'm just going to mark that. Now that we have our information, we've got 6 years here. Let's go ahead and write our equation. Now remember, it looks a little bit different. Y equals A times the quantity of 1 minus R to the T. A is 16,000. 1 minus, my rate is 7%. So remember to change it to a decimal. We've got to move the decimal twice. So I need to subtract 0.07 and to the T power, which is going to be 6. Now let's simplify this. We probably need to do it on a calculator just because we've got all these decimal points here. So it is a little bit easier. I mean, even I have to think through that sometimes. I'm going to do 1 minus 0.07. And I get 0.93. Now remember, I'm going to raise that to the 6th power. Oops. Okay, let's plug this in. 16,000 times 0.93, use the caret to the 6th power. And my answer is $10,351, and since it's money, I'm going to use 2 decimal points, 84, and put my dollar sign. So my car that was worth $16,000 is now only worth $10,351.84 after 6 years. Yeah, cars depreciate. Okay, one more, and then you get to try some on your own. Okay, a stock investment. Okay, you guys know what stocks are? Stocks are when you buy parts of companies, and if they do really well, then you also do well. So you can make money in stocks, but you can also lose money. A stock investment is depreciating. Notice it says D, that means it's going down. Depreciating at a rate of 3% per year. If the initial investment was $12,000, how much will it be worth after 8 years? So see, yep, stock is depreciating. Okay, let's start with our starting value. Where is our initial value? Oh, it's like buried in the problem. Do you notice that? Okay, now I need to know the rate. It is depreciating at a rate of 3%. And then I want to look at how much it's worth after 8 years. Notice that there's the time. Okay, so let's go ahead and fill out our equation. Y equals A times the quantity of 1 minus R to the T. A is how much my initial investment was, $12,000. 1 minus my rate. My rate is 3%, so I write 3%, but then I move my decimal twice, 0.03. Oh, and I notice, oh no. Okay, and then my time is 8. Now I am going to do the math on this on the calculator just because I want to make sure I am doing this correctly. 1 minus 0.03 is 0.97. 0.97 to the 8th power. Okay, let's type this in the calculator. $12,000 times 0.97, use the caret, to the 8th power. And this money is now only $9,404.92. Okay, that was a bad stock. Don't buy into that stock. Okay, now that is how you do growth and decay. Make sure when you're reading, you're looking for those words of depreciating and decreasing for decay, or you're looking for increasing or growing for growth functions. Okay, if you need help, just call me on over.